as well, I would like to welcome you on behalf of the Work Package 5 team. And well, we are a group from PSI, Christian Bauer, then from Rapperswil, the Institute of Markus Friedl, Alex Fürst from Berner Fachhochschule, so University of Applied Sciences in Bern. And he's in fact one of the professorships that started with the SCCER. So one of these things that I think really was the plan of SCCER. Then similarly, Martin Patel from University of Geneva, as well a new professorship in the context of SCCER, and in fact sponsored as well by, or given as well by SIG, so by the energy provider of Geneva. Then the team of Urs Sennhauser at EMPA, and then my team at University of Applied Sciences in Lucerne. So Work Package 5 is dealing with technology interactions of storage systems. So there are two words in there. The first one is interaction, that is really important, and system. So the task of Work Package 5 is really this interaction task. We have seen the different specific topics on batteries, on heat, on H2, and on catalytic and electrocatalytic CO2 reduction. And in Work Package 5, it's really about interacting in the sense of assessment, that we want to make sure that in the future we are developing and we are researching on the right storage techniques, so gaining know-how in this. Then interacting in the sense of making sure that we have topics in between those singularities of storages, and interacting in the sense of going to the industry and making sure that we are closer to the industry as well with our SCCER activities, overall SCCER activities. So in this presentation, I don't want to talk about all the work packages all through. I just want to zoom into some activities. And I want to give a zoom into assessment of storages in the energy system. Then two zooms into storages with a focus on interaction of energy grids. So one is power and gas on the one side, and the other one is power and heat on the other hand. And then I want to talk a bit about this role of the interaction platform with industry and with the other SCCERs that we are having in. So this is us, as mentioned before. And well, as said here, we already see a lot of cooperation, and we are really defining ourselves as one team working together here. I want to start with a slide that in similar ways has been shown in other contexts, for example from PSI as well, from EMPA. When we look at the energy strategy of 2050, we have, on the one hand, we have to work on new energy sources without nuclear part. On the other hand, we have to work a lot on the efficiency. And third, we have to work at in between, and that's where our storages are, that's where our SCCER is, in energy conversion, storage and transport, in new means, how we can do that better. And what we consider very important is that in all these considerations, we are not looking at one specific energy kind in particular, but that we always try to look as well at the interaction of the power grid, the gas grid and the heat grid. Of course, there are other cases, but in general, it will become more and more important as well to consider those together. Well, when we fill all that, then it's getting a bit crowded in here. I don't want to go into all these details, but of course we have all the different storage possibilities considering that, and we have some that are here in the interchange, And of course, we have to work closely together as well with the SCCRs that are active here and with the SCCR active on the efficiencies, for example. So first of all, a zoom into assessments of storages. And with this assessment, we, in the final goal, we really want to look at the whole energy system. Nevertheless, we are aware that we have to start from different sides. I mean, we can start on the one hand looking at certain systems in the energy grid, and this we can do by selecting certain model systems and then especially looking at the demand side. And with that, of course, we have to be aware that while we have today's situation, and on the other hand, we have to look into where we know the market prices, where we have the different values available, and we have to go more into the future, looking into, for example, 2030. Well, 2050 would be a bit too much, I guess. Being involved there as well in the International Energy Agency activities that are going there, we see that other countries are going there probably more or further there, like for example Électricité de France, that has already quite some good data about how they see exactly their market, and we think that we as Switzerland have to pick up there quite a bit. Well, then it's clear that the ideal situation would be we have a top-down approach. If we knew everything, what energy demand and what the energy system in the future would look like, we could boil it down to really the single storage system. What does each storage system need, and where are the parts? But at the end, it's more realistic that we have on the one hand a bottom-up approach and on the other hand a top-down approach, meaning that at the moment we are assessing single storages in their systems, knowing that this is not the overall picture, and on the other hand, in the long term, going for a top-down approach together with other SCCRs, together with SCCR Crest, for example, that is looking at economics, and together with SCCR Furies, that is looking into grids, to make sure that we are getting then the requirements for each single system. But one must see that this is really more in the long term. What's the methodology of these assessments, of these global assessments? Well, here it's important that we are not looking just at technology. We are looking as well at the economic assessments and at the environmental assessments, doing so especially in Geneva and in PSI, where there is already a long experience in life cycle assessments in general, and now a new group focusing in particular on storages and on life cycle assessment of that. Well, some zooms into specific topics. So, for example, for load shifting and energy arbitrage, one can find ways to define here what round-trip efficiencies one should reach, and there are quite some interesting works already in, for example, done in the US on different systems being compared, and of course it is a matter of size and discharge time, which systems make sense in a certain combination and in certain needs of the systems. And then, having talked about that before, when we look at the electricity prices, so at the end quantifying the value of the flexibility that a storage can give, then of course we have today's electricity prices in the Swiss market and in the control energy part, in the intraday market, and of course we have to put more effort into the work, how these will evolve and how the situations will look like. And well, here again some examples of how today's situation here is based on a 24 period retail tariff, for example. One other aspect that we would like to zoom in, because we think it's a very important part. This is what Andreas has mentioned as well from Work Package 2, is to have a specific look at heat storage in the Swiss industry. And as mentioned, well, at the moment we are in the situation that for Switzerland we do not have such perfect know-how. We are really relying here at the moment on data of the European Union. The goal in our team is really to get more and specific data for Switzerland to be able to know, well, what are here the needs exactly for the whole SCCER storage. Another zoom into assessment of storages. Here one particular item on batteries, looking into assessments of batteries in particular. And here this is done mainly at EMPA, and having long-term, so for a long time already, a lot of experience in material testing. They are now going more and more into storages and in particular into battery systems. And this is related to lifetime safety and reliability. And with that, giving on the one hand the feedback to the teams in Work Package 1, and on the other hand, then building up the industry contacts to work there. We can see here these SEM micrographs, for example, and on the other hand, it's done via physical models, how these batteries and the cells, how the battery cells evolve over time. Some more results from this team. For example, on cell performance, here seeing for different systems the during the charge and the discharge time, the cell performance, and as well data on the lifetime aging, so with many cycles, so here going up to 2,000 cycles, learning more about how then the battery cell as a whole performs, and not just, so the whole battery system and not just each cell alone. A second zoom I would like to give on storages with a focus on the interaction of the grids, where we have heard that already in the presentations just before. On the one hand, one zoom into getting closer to application of power to gas systems. And this is, there is a focus on this in the team of Markus Friedl in Rapperswil. And as well there is a demonstrator being built up currently. There is a close cooperation with industrial partners that are now planning and building up electrolyzers, and working closely with them, among others as well in Solothurn, where there will be a talk afterwards. So this power to methane demonstrator that is in planning currently is together with different industrial partners, and well, one can see some aspects here. For example, the absorption of CO2 from air, from the top, and then of course the electrolyzer, the methanization, and the storage, and at the end down to the fueling station for the car that can drive with it. So here again the goal to interact in the full range of bringing things down, being aware that of course efficiencies can still get better, and being sure that we want to start this kind of processes early to optimize as well in the in the applications of such systems. In parallel, for these kind of projects, as we are focusing on assessments, we would like to have case studies already with these projects. So making sure that that we are looking at the life cycle analysis from the beginning on. And of course, this will be the goal, to have life cycle analysis for more activities within the SCCER and to make that like a common tool. In order to start that properly, we have started that for the work package 5 activities at the moment. This is the group of PSI. In this case, closely working together with this power-to-gas demonstrator group in Rapperswil. And well, of course, here it's all the chain that goes through from the methanization, electrolysis, down to the compressor, to the storage, and so on. And based on the huge database here at PSI, then the life cycle assessment model can be done. Having a look at some preliminary results of that, while comparing conventional natural gas supply with a power-to-gas unit in the sense of emission breakdowns on comparison of total greenhouse gas emissions between a car with power-to-gas and a conventional one. And well, the big difference is, of course, the fuel combustion, because this is not part of the greenhouse emissions then anymore. But of course, we have more upstream processing down there with everything that we bring in. And well, similar in here, looking at greenhouse gas emissions breakdown in the gas production, when we just look at the gas production, as well here, looking at the different breakdowns into how, which parts affects that, that part. Of course, this is a start. And of course, on the one hand, for these systems, for this system, one has to go more into detail. And of course, the major goal is then to make this like a standard technology for all of us, for all of the SCCER, and then as well for general assessments, to compare then which systems do we suggest for the energy future in Switzerland. Then another zoom within the interaction of grids, in this case between electricity and heat. And here the activities mainly within my team in Lucerne. We are looking at a concept that has been proposed in the past. For example, ABB has worked on that intensely for some time. It is based on a system where a heat pump is used to fill a high temperature storage and a cold storage, so to pump the energy from a cold storage up to a high temperature storage, and then having a right turning cycle again going back into electricity. One can think of different setups in here. This can be a pure, let's say, huge battery in the sense of being closed here and working with electricity supply, and here based on the electricity demand. Moreover, one can go a step further and have really an interaction between the thermal grid and the electrical grid, and that's the direction where we think that there are in the future even more possibilities for that. There is a group of 5 people working on that currently now, and we have done first evaluation based on working fluids of CO2. This is what the ABB concept has done. Working, of course, at the end, it's important that we have very good heat exchanger functionalities and having the right turbines and heat pumps in place. Well, some results out of these optimizations. One can see that for a demo plant, so for a laboratory demo plant, we can get up to a round-trip efficiency of 0.5, knowing that, of course, with the scale-up, this changes then a lot because then the components are getting different and so on. Where we even have more focus on is when it comes to the interaction with heat and cold. So where we see today already in industry, for example, the demand of a cold source and the demand of a hot source. In the future, this can be on the one hand a thermal storage for such industries, and additionally, this can become an electricity storage. And here we are already in close cooperation with companies, and one of the working fluids that is looked at for these kind of cycles is NH3, so ammonia, like it's typically used as well in refrigeration units. As well here, we have started with the life cycle analysis, and of course, one has to go step by step. This is a long-term project. We have started to look at the pure electrical storage to keep things simple in the first part and then go into the next applications of combining it with heat and cold demand. As well here, work of course is still in progress. Then at the end, I would like to show some parts that have started already in the sense of being an interaction platform, making sure that the SCCER storage of heat and electricity is well connected, and taking here our role in that. So on the one hand, there are some conferences that have started, like the EMPA seminar on lithium-ion batteries. Then at University of Geneva. Then in Rapperswil, the expert talks on power to gas have started, and we are holding a Swiss Symposium, Thermal Energy Storage, an annual one, and from next year on, this will be part of the SCCER framework. We had 100 people last year, and let's see how this involves. And we have started some new lectures. We have built up new infrastructure in this short time now. Of course, this will hopefully go on, like at EMPA, like at our team, and like in Rapperswil. And very important, we are working very closely together with other SCCERs. For example, in this assessment of storages, this is in very close cooperation. This is mainly PSI, University of Geneva, and our University of Applied Sciences, together with SCCER Crest. So, and there in this topic, mainly the University of St. Gallen and so forth. And the next Work Package 5 meeting is taking place 1st of December, and this is together with SCCER Furies. So Mr. Paolone, Professor Paolone from EPFL will be there with his co-workers, and we will discuss first interactions, how we define that. And then, last but not least, some overarching teams have been started in Bern. There is the Energy Storage Research Center with in total 6 professorships working on different aspects, and there Axel Fürst is basically our link within this framework, and there it's the work together with mobility and as well with Furies. And then in Lucerne, there is as well one overarching team having people together from the different SCCRs. There it is mainly the interactions with efficiency, so efficiency in buildings and efficiency in processes, where as well the assessment of storages then comes into place and is related into that. New industry cooperations have been started, a lot in the gas sector, parts in the electrothermal storages, and at EMPA they're building up EMPA reliability pool, and so far they have 28 industrial partners already within their framework. So at the end, SCCR is all about competences, competence build-up. In total, now we are at a plus of about 15 additional researchers in the team. Some photos are here. And approximately 5 more it will be till the end of the year, what will be an add-on at the moment. So far to our side and to some zooms and to some spots out of Work Package 5. Thank you very much.